All right, the next unit we're going to discuss is that of climate, which is in your Weather and Climate book, Chapter 3. So as we begin to talk about climate, we want to discuss the difference really between climate and weather. Let's use an analogy that we can all relate to, that being your grades. Weather would be a lot like taking a look at one specific thing. So let's say maybe one test or one homework assignment. That would be an example of weather. Weather we look at on a day-to-day basis, maybe even an hour-to-hour basis. Okay, but it's just that. It's one grade, one particular thing. Climate, on the other hand, doesn't focus on one particular thing, or in our analogy, one particular grade. It's going to be a culmination of a lot of things. Things like, it's going to factor in things like all tests, all homework, all quizzes, and all labs. So really, when we're looking at the grade analogy, the climate is more like your overall grade. So section 1 deals with what is climate. Well, at first let's take a look and let's discuss the difference between weather and climate. Weather we learned about in chapter 2, and remember that it's the conditions of an atmosphere at a particular time and a particular place. Again, the weather's going to change every day. We know that. We got a good example of that in Michigan about every other day. One day it might be 55 and sunny, and the next day you wake up with 4 inches of snow. Okay, that's weather. Again, particular time and a particular place. Climate is the average weather of an area over a long period of time. Okay, so we're not looking at a day-to-day basis here. We might not even be looking year to year. We might be looking decade to decade, or maybe even 20 to 30 years at a time. Okay, so climate is, again, it's an average. It's taking a look at the big picture versus just the day-to-day thing like weather. Okay, where do we throw and how do we group things by climate? Well, generally it's going to be determined by two major factors: temperature and precipitation. This world map gives us a great example of how many different climates are found throughout the world. Okay, even if you just take a brief look at our country or our continent even, you can see a lot of the different colors there, and looking at the key at the bottom, you can tell that there are a lot of different areas, a lot of different temperature and climate regions, okay, found even just within our own country. Okay, a lot of this is going to have to do with the latitude. And again, we've discussed this a couple times in class already when we talked about ocean and water in general. But remember that latitude is the distance north or south in degrees from the equator. In general, the higher the latitude, whether it be north or south, is going to be the colder the climate. Okay. Why does this happen? What's the difference? Well, again, remember that our Earth is on a slight tilt. Okay? So it has a lot to do with angles. The angles then from the sun's energy as they hit the Earth. Okay? The equator is equal to a 90-degree angle, okay, or close to it. Okay? Again, as we work closer to the pole, we're getting a less and less angle, and therefore producing those colder temperatures. Although this picture is cartoonish, okay, it really does give a pretty good look at how this happens. Again, notice the two arrows, one pointing more towards the pole and then one pointing closer to the equator, and you can tell just by that slight tilt that's in the globe right here, okay, that the angle that those sun rays are going to hit the Earth are certainly going to be different. This tilt is also what gives us different seasons at different latitudes. Again, depending on where they're at in the globe, based on that latitude, okay, may cause a change in temperatures with seasons, or the temperatures may stay consistent depending on the tilt or the axis of the Earth. Here we have a picture that will show how the tilt of the Earth and its rotation or orbit around the Sun will cause these different seasons. You'll notice that the summer and winter solstice for us in North America is due to the tilt. Summer obviously being closer to the Sun, and winter we're tilted slightly away. Okay, the autumnal and the vernal equinoxes, on the other hand, will be those in-between seasons that we generally call fall and spring. Now we want to talk a little bit about what is going to affect climate. One thing is prevailing winds. These are winds that blow mainly from one direction. They're going to influence the moisture and the temperature that we've talked about. And again, remembering back to what we just talked about in Chapter 2, weather, that warm air has a higher capacity to hold moisture. So therefore warm winds tend to carry moisture. Cold air, on the other hand, doesn't carry as much moisture in it. So when warm air loses its ability to hold the moisture, meaning that it's cooled down, right, we have this thing called precipitation, which we've talked a lot about this year already. Okay, winds over land then are going to be dry, and winds that form over water will in turn be wet. Some other things that will affect our climate are going to be geography. Remember that elevation has an effect on precipitation. Therefore, things like mountains will certainly affect climate. Another thing is ocean currents. Remember back to when we studied about how the ocean currents and the way that they circulate is going to cause like eastern borders to be influenced by warm water, while the west coast of different countries is going to be affected by some cold water currents. Here's an example, one that we did during that first unit when we talked about water. Remember, the red lines and arrows are representing the warm water currents. The blue arrows and lines are representing the cold water currents. One tool that's used quite frequently when studying different climates is a climatograph. Really, it's nothing more than two graphs combined into one. It's going to graph both the temperature and the precipitation on the same graph. Temperature is the line graph, and it uses the left y-axis. Precipitation, on the other hand, is the bar graph, and it will use the right y-axis. So again, when you look at these, or when you make these, when you're considering the temperature, you use the left y-axis and the x-axis, which is actually the months, and totally ignore that stuff on the right. When you go to do the precipitation graph, it's the opposite. You're going to ignore the temperature stuff on the left and strictly use the precipitation numbers on the right, along with the months of the year again, to complete your graphs. So again, what this allows us to do then is have two separate graphs combined into one that will allow us to compare how temperature and precipitation are going to vary between different climates. That completes the notes for Section 1 in Chapter 3, Climates. Make sure you fill in your notebook and your note sheet, and make sure you put them somewhere where you won't lose them. Have a good night.